Hello, I'm Anastasia Kuzminykh, and this is a video presentation of work published at CHI 2020 that was done with my colleague Sean Rintel at Microsoft Research Cambridge. In this work, we explored what does it mean for a system to recognize attention during video-mediated meetings. And the primary motivation here lays in the current conceptual gap between what a system can potentially recognize in a video stream and what is functionally reasonable to recognize, and how can we meaningfully process these data. Specifically, there are a number of available computer vision mechanics, for example, being able to recognize a person, their identity, their pose, their gaze direction, a number of objects in the environment. And our goal was to figure out how these very granular computer vision mechanics can be used to support attention in teleconferencing meetings. And to approach this task, first, it was crucial to understand what it actually means to support attention. Because attention, as a set of cognitive processes, plays as much in our sense-making abilities as it does in our physical abilities. And this means that it is not enough to be able to just see things. We need to understand what is meaningful to see, what is meaningful to recognize, and to support. We decided to focus on work meetings, and besides looking deeply into what other people have done previously, we have also conducted 2 studies on sense-making and selectiveness of attention in work meetings. We first conducted semi-structured interviews to explore what aspects of visual attention contribute to participants' engagement in meetings. And we also wanted to see how these aspects are affected by remote participation. And then, to further probe the emerged themes, we conducted a quasi-experiment in which we asked people to narrate silent video footage of work meetings. We did that because we wanted to see what people are going to notice in this pure visual information and how they are going to prioritize and interpret this. So these results provided us with more granular and procedural understanding of user sense-making of the observable information on attention. We synthesized our findings into a 3-level functional classification of visual attention in meetings. And the top level here represents 3 categories of attention that a video meeting feature might potentially support. First category is attention as direction, and this is purely observable attention that constitutes only an observable process, but no interpretation of its purpose. For example, Alice is looking at Bob. Here, we need to recognize a person, who is called Alice, a person, who is called Bob, and Alice's gaze directed at Bob. And we already know how to do it more or less. The second category is attention as action, and this reflects attention processes that are both observable and have a specific interpreted purpose. For example, not just Alice is looking at Bob, but Alice is addressing Bob. Third is attention as state, and this is the overall sense of engagement. It doesn't include any observable processes and reflects only an interpretation, a purpose of such attention. For example, Alice is attentive. The second level of classification represents functions, so these interpreted or recognized purposes of each type of attention. And for attention as direction, as we said, there is no recognized purpose. For attention as state, the recognized purpose is this general sense of engagement, so to be mentally there. And then, in our work, we have identified 3 functions of attention as action, so this purple part in the middle. These functions include information gathering, when we look to see or listen to hear, communicative signaling function, when we look to be seen, and then process following function, look to be a part of a process or look to participate. Finally, each of these functions of attention as action corresponds to a set of functionalities within a work meeting. These functionalities are specific tasks and activities performed through the attention actions. And this forms the 3rd level of the classification. For example, gathering reactive social information refers to collecting information on how people reacted to one's actions. At the same time, gathering proactive social information allows users to assess who is present, for example, what is the social environment, or say when is it appropriate to start speaking. Signaling function allows to address a person by looking at them, or, for example, to demonstrate the intention to take turn in speaking. Finally, following function allows to work around an artifact, such as an object on the table or, say, a whiteboard, and it allows to focus on one thread of conversation when a discussion in the room splits into several streams. Since attention as action constitutes both an observable action and its interpretation, its recognition, of course, is predicated upon attention as direction. But interestingly, the results from both of our studies also showed that the ability to perform this purposeful attention action, so this purple side in the middle, also significantly contributes to the overall sense of engagement of meeting participants. And so while keeping remote participants generally engaged and mentally checked in is the ultimate goal of feature supporting users' attention, and on the other hand, attention as direction is the only one that is directly detectable and strictly available for machine vision, attention as action has both detectable structure, meaningful functionality, and it affects participants' engagement. So we suggest that attention as action yields the most promising initial directions for attention-based feature development. And with that, I would like to thank you for listening and invite you to read the full paper for more details on this work.